Okay, so this is the second tutorial, and what I'm going to go through now is what you do once you have worked out your percentiles, the 5th, 16th, 50th, 84th and 95th, for each sample, so sample 1 to 3, from the Excel spreadsheet you've downloaded from Blackboard. And what we're going to have to do is import these values into MATLAB. Now what I'd like to just mention before I carry on is the fact that the process of hovering your cursor over your particle size distributions in Sigma plot will mean that some of these values for your percentile will differ slightly. Okay, so whether you hovered it over for the 5th percentile at 5.01 or 5.09 will mean that you'll end up with a slightly different phi value, and I will reflect that in the marking scheme, so don't be worried about that. Just make sure you get 5.0 something or 16.0 something and your values will work out fine. So let's get the data into MATLAB. So what I'm going to do is I'm going to select the data. I'm going to press Ctrl C from my Excel spreadsheet. Now in MATLAB, I'm on the Home tab and I'm going to press New Variable. And then in this new variable, I'm going to press Ctrl V. And my data has been copied or pasted, sorry, into this new variable. I'm going to close it and I'm going to right click because when MATLAB creates a new variable it just calls it unnamed because obviously it doesn't have a name. So I'm going to rename it all samples. Press enter. Okay. So now in my workspace I have a variable called all samples which has the sample number in the first column, the 5th percentile in the second, and so on and so forth to the 95th percentile in the 6th column. So this is what we're going to do, this is what we're doing for the computer practical, but it's exactly the same as what you're going to need to do when you're working up all of the data for your Sediments assignment. So now you've created this as a variable, it would be a good idea to save it, and you can save your workspace by simply writing into the command window save and then give it a name. So I'm going to call it all samples, which is the same as my variable name. You wouldn't necessarily do that every time that you save your workspace. So right, save all samples, press enter. Now what you see coming up in the folder that I'm working in is a mat file called all samples. So that means that if I stop working now, I can go away. If I stop working now, then if I want to come back to this data set, I have it saved there. Okay, so let's just test that. So if I do CLC, that clears my command window, and if I write in clear all, that clears my workspace. So now, pretend that I've gone away and then I'm coming back to my data. If I want to load that mat file, I simply write load all samples and press enter. And that means that my mat file here opens up in the workspace, and it will open up with however many variables were in your workspace when you commanded it to save. It's worth mentioning, in case you're not kind of already in the practice of doing this, make sure that you are in the correct directory for where you're trying to work. So if I wanted to load all samples.mat, I needed to be in the same directory as that to do so. If I wasn't in the same directory, I would need to provide a path for MATLAB to be able to find that file. It's very clever, but yeah, it can only do so much. Okay, now ideally you want to be working in a script. Okay, and you can open those by open a new one by just pressing the plus button on new script. I've got one that I've just been working on. I've called it Sediments Exercise Computer Prac. And in the practical, I was talking about the importance of commenting your script. So what I've done here is I've said that it's a MATLAB exercise. You may also want to say what it is that you're doing in this script. So you're importing particle size distribution data to calculate graphic mean, sorting and skewness. So that would be a useful thing to write in your comment section. So as long as you put these percentage signs before you write something as a comment, then that means that when you run this, MATLAB won't run whatever's commented, it'll only run the uncommented sections. So what you want to do initially is organise your variables within this variable. So within all samples I have the column 1, which is my sample number, so I've just written that as a comment. Column 2 is D5, column 3 D16, etc. So I know what column is which. And now I can name these variables to make the calculations a bit easier. So I have extracted the data for D5 from all samples, and I've done that by doing all samples open bracket colon, which means you're asking MATLAB to identify all the rows, and then comma, and then highlighting which column you're interested in. So this is all rows column 2, which corresponds nicely to the D5 in here. Now you go ahead and do that for the rest of the columns, and that means you can then quite neatly get on and calculate your graphic mean. So what I've done here is I've written the equation in commented form, and then now I've got the equation where it will calculate it. Okay, so I've got the equation which corresponds to the equations in your Excel spreadsheet. So what you need to be careful with these is making sure you put brackets in the right place. And for the graphic mean, it's quite simple. You're just adding the 3 columns together and dividing it by 3. So that's quite simple. You can just write that like that. But when it comes to the sorting or standard deviation and the skewness, it gets a little bit trickier. And as I mentioned in the computer practical, because we are in this case subtracting and multiplying and dividing matrices, so a matrices is any variable that has multiple rows and multiple columns, so we're timesing those by other values, which means MATLAB needs you to tell it to do those multiplications row by row, and you can do that by so for a division you would press full stop and the divide sign, and that tells MATLAB to do the division row by row, or if for multiplications, do it a dot before the star, and that's something you're going to need for the equation for the skewness. Okay, and In this tutorial I'm not going to write out all of these equations in MATLAB because that's part of what I want you to do in the assignment. So have a go at that, and if you do have problems with it you can get in contact with me via email. So that's all for now. Thanks for listening.